Hi there. What you're looking at is several overscoped projects that started bleeding into each other. The result is a very simple HTML parser that runs in 3 passes that displays the resulting tags and tokens in egui. By the time I make a video about it, it feels pretty boring, but at the time it was kinda neat clicking through almost 330 tokens that get created from my HTML ramblings. When I first learned how parsers worked, it seemed kinda like magic in a weird way. It was kinda cool to see a program I made turn a block of text and symbols into actually useful tokens and commands. I think it's because I started to realize how many tools are just parsers with different coats of paint, and knowing how they work opens the door for a lot of potential projects. If you're at all interested, you should go check out the free web version of Crafting Interpreters by Robert Nystrom. It goes through the basics of making an actual programming language. The examples are in Java, but I didn't find it too hard to adapt them to another language. The core knowledge is pretty transferable. Most of what I did here is half remembered from that book or from similar books that had overlapping information. If you really get interested, you can read the Dragon book and learn about compiler generators, regular expressions, and other similar stuff. I don't have any affiliations with any of these, by the way. They are just some of the resources I've used in the past that I found helpful. So, to start with, HTML stands for Hypertext Markup Language and organizes text and data into containers that allow web pages to be built into human-readable catalogs of information. There are a lot of other ones, possibly a couple hundred, but the only other ones I've heard about recently are LaTeX, which is used for formatting scientific papers and books, Markdown, which is used in various forum posts, Discord messages, and the like, and bulletin board code, which I think was kinda used how Markdown is now, but now it's used in the Godot game engine to format rich text. Markup languages are different from data serialization languages like JSON and YAML, which mainly are meant to pass data in an easily parsable format between languages and programs. I found out fairly recently that YAML doesn't stand for yet another markup language, and was instead changed to YAML ain't markup language to reflect its use. Okay, so HTML is used in web browsers to form web pages along with CSS and JavaScript. It gets formatted into a tree structure called the Document Object Model, or DOM, that gives a hierarchy for how elements are placed onto the page. In order to create the structure, I first parsed the text into the tokens that we were looking at near the beginning of the video. This process basically just looks like looping over each character and matching possible patterns. In this case, we end up with a very similar result to the characters we started with, but we can group the strings together to reduce some complexity. This step is called a lexer, which comes from lexical analysis. You get a little more utility out of it in proper programming languages because compound symbols and keywords can be turned into tokens as well, but it's nice to just be able to focus on symbols and strings for HTML. Next, I parsed the tokens into parser tokens, which I've categorized into opening tags, closing tags, and data. This step also somewhat awkwardly tokenizes attributes for opening tags into key value pairs stored in a hash map. I basically have a function that expects a closing tag if there's a left angle bracket and a slash, and another function that expects an opening tag if there's a left bracket and no slash. If it is an opening token, I'll check to see if it has attributes to parse as well. It also has to check for an exclamation point or bang to handle doc types too. Anything left is considered data and gets grouped together until the function finds a left bracket. Oh, right, and comments were turned into tokens in the first step, and they just get discarded here. The last step converts these parser tokens into HTML tags with HTML tag types and content strings, and then creates the tree structure. I created a root node for the base of the tree and then loop through the tokens to create the child tags while linking the parent and children IDs to create a tree structure. Rust doesn't really like linked list-like structures, so all of the tags are stored in a hash map with an ID number, and the parent variable and child vector of an element contain the ID number corresponding to a node in that hash map. If you're interested in making a parser, I personally think that making a proper programming language like locks from Crafting Interpreters is just an all-around better experience than a markup language. It's more satisfying, and frankly, as someone who doesn't have a ton of experience with HTML or making parsers, I'm not sure that HTML warrants having a full parser. It's possible you might be better off just brute forcing a match statement or switch case for every tag rather than trying to be overly fancy about it. Ah well, it's kinda neat to click through the tokens. That's about it. My original goal was too ambitious, and it had already been several weeks since I wanted to release another video. If you want to and are able to support projects like this one, I have a Patreon in the description. The support helps me to make these, but I also want the content to be free to everyone, so I don't have much to offer supporters other than my sincere thanks right now. Thanks for taking the time to watch, and I hope to see you in the next one.